Hi, welcome to just a quick video on double angle formula from the trig topic at higher maths. What we're going to look at is just using the sine 2x and cos 2x to simplify expressions. Now, this is very similar to your addition formula in that it is a formula that's given on the formula sheet that you just have to recognise and use. Okay, so I'm not going to do the proofs. I'll just take you into what they are and how to use it. So these are your expansions for sine 2a and cos 2a. These are called the double angle formula. Okay, just the one for sine 2a. So if you see anything sine 2x or sine 2 theta or whatever, you can use just that one to do it. But we do have three options for cos. And what one you use depending on what information you have. It matters a lot more when you're doing trig equations with them, but generally you can use whatever one you like and whatever one you feel is suitable. Okay, so, and also, sorry, remember that sine squared a really means sine a all squared. Okay, so given that theta is an acute angle with cos theta equals 5/13, find the exact value of cos 2 theta and sine 2 theta. Okay, so firstly, because we have a trig term, we can use that to draw a triangle. Okay, so the triangle we draw is going to be with theta. Cos, remember, is adjacent over hypotenuse, so the adjacent to that theta will be 5, the hypotenuse will be 13, which makes your opposite 12. Now, cos 2 theta, we can use whatever one of the functions we like, whatever one of the expressions we like. I'm going to use this middle one because I've already been given cos, and I don't really need to worry about using anything else in. So it's 2 cos squared theta minus 1. Okay, so subtract 1, which means we're doing 2 times 5/13 squared, subtract 1. Okay, so 5/13 squared is 25/169, times 2 is 50/169, subtract a whole, which is going to be negative 119/169. Okay, so the value of cos 2 theta in this case is negative 119/169. Okay, sine 2 theta, we only have one expansion for that, and that's 2 sine theta cos theta. Okay, again, just from the formula sheet, which means we're doing 2 multiplied by sine theta, which is 12/13, multiplied by cos theta, which we already know from the question, is 5/13. Okay, and then just calculate that. 12 times 5 is 60, times 2, 120/13. Oh, rubbish, I've not multiplied the denominators. 13 times 13 on the denominators is 169, apologies. Okay, so again, we've got the expansion, we'll use the expansion, we're using trig triangles quite a lot within this as well. Okay, and the next one there, cos 4x in terms of sine 2x. Write cos 4x in terms of sine 2x. Now, just to go back here a second, although the formula sheet will use 2a and a, these are valid for everything where the angle on the left here is double the angle on the right. So if you wanted to do sine 2a is equal to 2 sine a cos a, sine 2a is equal to 2 sine a cos a, and that's exactly the same as saying, well, sine of 10a is equal to 2 sine 5a cos 5a. The same as saying sine 100a is equal to 2 sine 50a cos 50a, or sine 20a is equal to 2 sine 10a cos 10a, as long as this angle is double that angle. So we want to write cos 4x in terms of sine 2x, so that's good. And we're going to pick this bottom one here, because that's one that only uses sine. So cos 4x in terms of sine 2x, uses cos 4x is going to be 1 minus 2 sine squared 2x. Okay, and that is writing it in terms of that. Okay, so just be aware of that. It doesn't just have to be 2a and a. It can be 10a, 5a, 40a, 20, as long as the angle is double on the left and the right. Okay, now that's it. You'll get a lot more practice with that in class, obviously, and you'll use it in the next video with solving equations, but you need to just be on top of that. Okay, thank you.